Hi, I'm Curt Frye. In this movie, I would like to extend analysis we did on the knapsack problem to include multiple containers. The sample file that I'm using, knapsack_multiple containers, can be downloaded using the link that I provide in the video description below. The idea with the knapsack problem is that you want to fit as much weight or as much volume or as much value into a container as possible. In this case, we've gone from a single container to 5. So let's take a look at the worksheet. I have a total of 17 packages, and then our controlling variable is the weight. So I have weights assigned to each of my packages. They range from 2, and it looks like there's a maximum of 25. And then the changing cells will be the container to which each of those packages is assigned if it's used at all. Then to the right, I have a table with the containers and the capacity that they can handle. In this case, again, it's weight. And there's no guarantee that each of the containers that we fill will go to its maximum. So I have a total capacity of 270. And you can tell if a project is at least feasible by ensuring that the capacity is greater than or equal to the total weight that can be sent. So I have no idea if we can fit all these packages in, but I know that at least theoretically there is enough capacity for it to happen. And then I've calculated unsent weight. That's because what I want to do is minimize the total of unsent weight and maximize what has been sent. Then further to the right, I have a table of 5 containers, and I will calculate the load that is assigned to each one. So let's do that now. The formula that I want to use is a sum if. So I want to look at the containers and see what the assignments are, and then add the weight for any packages assigned to a specific container to their load. So in cell I4, I'll type equal. We're doing sum if, and the range will be C4 through C20. And I want to make that an absolute reference, so I'll press F4. That's because we'll be copying the formula down, then a comma. And the criteria will be the value in H4. That's the container number. It's hidden by the formula preview, but I believe it's there, then a comma. And the sum range will be the weights, and those are from B4 through B20. So I'll select those. I've selected that range, F4 to make it an absolute reference, again, because we're copying, right parentheses and enter, and I get a total of 238, and that's because I have everything assigned to container 1 at the moment. Then I'll click cell I4 and drag down the fill handle, and so now I have 238 all the way down, and then under I8 I will re-add the bottom border because copying the formula actually included the formatting. So there's that. And then just to make sure that all of my formulas are working, I will update so I have containers 1 through 5 here in the changing cells, and it looks like the calculation is correct. So with that in place, I can create my solver model. So I'll go to the data tab of the ribbon, click solver, and I want to minimize the unsent weight. So the objective cell, which I have marked in green, is F11, and I want to minimize that value, and we'll do that by changing the variable cells of C4 through C20. Now we need to identify our constraints, so I'll click Add. The first constraint will be to make C4 through C20 integer values. So no decimals allowed. We are assigning discrete values. So C4 through C20, and then the comparison operator will be int for integer. We're good. And we want them in the range 1 to 5. So the cell references again of C4 through C20 must be less than or equal to 5. Add. Same cells, must be greater than or equal to 1. Click Add, because I also need to ensure that no container can be assigned more than its capacity. So for that, I4 through I8 must be less than or equal to the values in F4 to F8. And it helps a lot to have parallel structure in your solver model worksheets. So I go from row 4 to row 8 for both the load and capacity. That looks good, so I'll click OK. We're using SUMIF, which means that we are no longer nonlinear. This is an evolutionary problem. So I'll click the solver engine down arrow and click evolutionary. Then I'll click options, and I'll just ensure on the evolutionary tab that I have require bounds on variables selected. Everything else I can just leave alone. So I am requiring bounds on variables. That's what the 1 to 5 range was giving us. So OK. Then I'll click solve, and hopefully in a moment we'll have a solution. We do. So it looks good. I will click OK to see what our solution is, and we are able to get everything in. So we have an unsent weight of 0, and it appears that all of our loads are below the container capacity, so we have a successful solution. I hope you enjoyed this video on extending the knapsack problem analysis. If you did, please like it and subscribe to my channel.